My name is Neil Hiller. I'm the Vice President of Business Development for Vigitron, Inc. Vigitron is a 15-year-old company which is a leader in the field of extended distance video, power, and data transmission. About 4 years ago, as the industry changed, we migrated into the field of IP transmission. At that time, in assessing other technologies that were available in the field, essentially developed for cable and short distance transmission and based on VDSL2 or power transmission, we realized that those technologies were not adequate for long distance IP and PoE transmission. Primarily VDSL2, the primary technology, has two distinct disadvantages. One, bandwidth significantly drops off with distance, and second, upload and download speeds could vary by about as much as 40%. As a result of that, and the fact that Vigitron, an engineering-based company, developed our own products and technology to address the issues of extended distance transmission. Basically, these two technologies involve themselves around two significant factors. The first is called symmetric bandwidth. Symmetric bandwidth guarantees that bandwidth remains flat throughout the entire quoted distance, whatever that quoted distance is, and that upload and download speeds are absolutely symmetrical with no loss. The second technology, which is patent pending, is called pass-through PoE, and it allows our products to operate our transceivers without the need of local power, eliminating the need for local power supplies, local power sources, but more importantly, this technology does not require the use of repacketization and therefore eliminating the need for high power sources. Now, why are these things important? Well, first let's start with the idea of why the technology is needed in the first place. It's needed because in most applications there are over 10 million, approximately 10 million analog systems today with coax cabling that is greater than 100 meters or 328 feet. So that requires the need for transceivers in order to extend the distance for IP camera application, eliminating the need for pulling cable and reinserting cable, which is very expensive. In newer installations, the use of extended distance UTP cable comes into play because UTP cable, as opposed to coax, allows for either greater distances. Primarily, when we talk about the transmission of both PoE and IP cameras over coax, we're essentially looking at approximately 1,800 feet, and when we look at UTP, we're essentially talking about distances of about 3,000 feet. Now again, I want to emphasize the parameters of the equipment itself. Over here, we have two types of transceivers. The one with blue is UTP, and the one with red is extended distance coax. And again, I want to point out that both of these have the need for no power supplies whatsoever. Furthermore, because of that, and without repacketization, they run extremely cool. If you were to touch these here, you'd feel that these have been operating all day, but they're extremely cool. Because of that, they comply under NEMA TS2 traffic safety standards from -40 to +75 degrees. So not only can they operate in extreme temperature environments, which is the same as traffic lights or lights that are used on highways, but they also increase the reliability of the equipment because we're not cooking the components. Furthermore, other types of products that need this high amount of power push the power through in order to achieve PoE. By doing that, they cut off the communication that's inherent in the 802.3 standard between the camera, the PD, and the PSE. This means that if there's a short and the communications are cut off, the transformer, and unfortunately this is the case, literally can melt down or short out the products themselves, leading to defects. The next area that I want to point out is multi-camera operation. If we can maintain 100 megabps transmission, we essentially will have somewhere in the range of about 54 megas left for cameras. This means that if a camera has 2 megabps, we can literally put 25 cameras or so down a single line. Some people or some solutions take 5 of these and put them together in a hub configuration. Hubs are not to be used for high video transmission because we're moving around very high packets at very fast speeds, which result in collisions. What we devised here is a full layer 2 network switch with both extended distance Ethernet and coax transmission. This avoids any sort of collisions and is fixed for operation at high packet levels. Now, normally you would say the addition of any such product would cause a security problem within a network. But what we've done is we've fixed managed these, so we remove the IP address, and therefore there's no hacking or IP addressing. The other area comes into play is PoE power itself. Quite often, a lot of people don't realize that standard types of PoE switches these days do not provide enough power for IP cameras. They were not designed for IP cameras. Certainly as demands go from 802.3 at 15.4 watts to 802.3 AT at 30 watts, and now 60 watts at what's called PoE++. So they don't provide the power to it, and quite often, therefore, will not work. Or, in the case of IP cameras that have what we call auxiliary features, day-night operation, auto back focus, LEDs, PTZ, there's a high surge current that occurs. And if the port cannot handle these, as in many cases, they will shut down, protecting the product, but therefore shut down operation. So as a result of it, we designed our VI 2200 series, available in 8 and 16 channels, to have special features. First of all, our philosophy in PoE is that there will be no power sharing per port. The second is that no port will be under 30 watts. And the third criteria is that it will maintain the PSE to PD communication to protect the camera. These have individual power up to 34 watts per channel. But more importantly, these are programmable so that each port can recognize the need of a camera for inrush current and not shut down. Thirdly, these are individual capacitively fused. But here's the real key to our system. Each port is monitored in 10 different stages of operation. We have a very sophisticated algorithm that monitors all the ports themselves, and you can actually read this out on a computer as to its status. As a result of it, we can have things like programming for inrush current, programming for force current that maintains the safety in the operation, so that when it sees a need for inrush current, it won't automatically shut down unless it's a permanent condition. But the algorithm polling is faster than the blow rate of the fuses. So if it detects a serious problem, it will shut down the port faster than shutting down or blowing the fuse itself. Just as important, if the condition is outside the system itself and it goes away, the port will restart power, therefore saving a service call by reinitiating power to the camera and restarting it. We work with many, many camera manufacturers, and in fact, we have written endorsements from several of the major camera manufacturers on the floor today at ASIS, as well as the fact that every camera that we list as a partner camera is totally specified by us and totally engineered by us so that we know the power, the maximum power capabilities of that camera. And that's what's contained in the Design Center service that's provided to customers free of charge if they provide the most basic information. But as a result of our work, primarily with camera manufacturers such as ASIS that have PoE requirements at 60 watts, we developed our 2700 series, which can provide 60 watts of power, again, using our proprietary pass-through PoE requiring no power supply at the camera location itself. We can provide up to 60 watts at distances of up to 1,000 feet. More importantly, this provides full camera power. The other thing is, many camera manufacturers have moved from Class 2 power at approximately 7 watts at the camera location to requiring a full 12.94 watts or a full Class 4 of 25.4 watts, again, because of the reasons of all these auxiliary functions that are inherent with the camera. We have two methods using our mid-spans in conjunction with our 30-watt capable transceivers to provide long-distance full 802.3 AF and full 802.3 AT power, as well as 60 watts, so a total solution. Finally, there's the question of network switching. We have found through our customers that many network switching chips only provide up to 1518 bytes, the extent of RFC 2544, at the 100 megabps because they were designed for data applications. If the switch has the ability of 1G, they provide full 9,000, 9,600 bytes, full jumbo frame capacity. So many customers that are using high-end cameras such as Ericon or a Vigitron or those are finding that they can't pass those high packets through 100 megabit type of mode. But unfortunately, when you plug in these cameras, these ports register at 100 megabps and therefore delete the whole system. Now, you could force it into a 1G, but then you can't go extended distances. So what we did was we worked with a major switch manufacturer, Planet Technologies, and developed non-PoE switches that comply with jumbo frames, the full jumbo frame extent at 100 megabps, and provide a switching fabric so that the full bandwidth can pass even when all ports are fully loaded to their capacity. The combination of our midspans and these specialized network switches provide a full infrastructure system and take away the complexities of dealers of saying, will my equipment work together? Will it pass the camera? I want to emphasize that a manufacturer's responsibility is not just product, but it's education. And at our website, www.vigitron.com, you'll find complete white papers, application notes, and again, I want to emphasize complete design center services where we will create your entire infrastructure matched to your specific application. We hope you'll visit us, and we look forward to working with you. Thank you.